Day 383 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3024, type of triangle. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero-index integer array nums of size 3 which can form the sides of a triangle. A triangle is called equilateral if all sides are of equal length. A triangle is called isosceles if it has exactly two sides of equal length. A triangle is called scaling if all of its sides are of different lengths. Return a string representing the type of triangle that can be formed or none if it cannot be formed. All right, y'all. So that sounds simple enough, but let's go ahead and take a look at these examples just to make sure we are doing this problem correctly. So in example 1, we have the input nums equals an array of integers 3, 3, 3. These 3, 3, 3s represent the length of each side of a triangle. The output is equilateral because explanation says since all of the sides are equal length, therefore it will form an equilateral triangle. So once again, each one of these integers represents the length of a side of a triangle. So if all sides of the triangle are the same, it's an equilateral triangle, so we return equilateral. Now let's go ahead and look at example 2. In example 2, we have the input nums equals an array of integers 3, 4, and 5. This time the output is scaling. Explanation says nums 0 plus nums 1 equals 3 plus 4, which equals 7, which is greater than nums 2, which is 5, right? So if we add two of the sides together, they have to be greater than the greatest length of one side. So two sides added together should be greater than the greatest length of just the longest side. So let's keep going. Nums 0 plus nums 2 equals 3 plus 5 equals 8, which is greater than nums 1, which is 4, and nums 1 plus nums 2, 4 plus 5 equals 9, which is greater than nums 0, which is 3. Since the sum of the two sides is greater than the third side for all three cases, therefore it can form a triangle. As all sides are different lengths, it will form a scaling triangle. So once again, when we add two sides together, they should be greater than the odd remaining side. Sorry, I said it wrong earlier. But if we add two sides together, they should be greater than the side that's not included in the addition, right? So in this case, if we add 3 and 4 together, that's greater than 5. If we add 4 and 5 together, that's greater than 3. And if we add 3 and 5 together, that's going to be greater than 4. And that's what we need to satisfy the conditions to mean that we have a valid triangle. If say we add two sides together and it is less than the remaining side, then we know it's not a valid triangle. And in a case like that, we could just return none. Boom. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Let's take a look at these requirements as we write the solution because they're going to be important when we're writing our code, or excuse me, these requirements when we write the solution. So first thing we are going to do, y'all, is we are going to sort the nums and norms and nums. Sorry, we're going to sort the nums and nums, sort the numbers and nums. So, and that's going to help us make the side lengths comparisons easier. So for that, we're going to say let nums equal nums dot sorted and put the parentheses at the end. Now we need to check that the triangle is a valid triangle, right? So the sum of the two smaller sides should be greater than the length of the larger side, or the sum of the two sides similar to this should be greater than the remaining side that has not been included in the sum. Similar down here, like the sum of 3 and 4 should be greater than 5. Sum of 4 and 5 should be greater than 3. That's what we're about to do now. That's what we're going to handle now. So we could come right here and we could just say if num square bracket 0 plus nums square bracket 1 is greater than nums square bracket 2. So on this side, in this case, we're just checking to see if the two smaller elements, if we add them together, if they're greater than the larger element, right? Because if the two smaller sides, when we add them together, they have to be greater than the larger side. So since we sorted nums 2 will always be the larger side, and nums 0 and 1 will be the smaller sides. So then we need to check if all three sides are equal. That means we have an equilateral triangle. So we could say if nums square bracket 0 equal signs nums square bracket 2, we could open up the brackets and we could say return, open up quotation marks for a string and say return equal lateral. Sorry, y'all, gotta make sure it's spelled right. Equilateral. Boom. Now, since we sorted these, right, remember nums is sorted, so we don't have to check nums 1. If nums 0 and nums 2 are equal in a sorted array, then we know nums 1 is going to be equal as well. Then we need to see if exactly two sides are equal, then that means we have an isosceles triangle. So for that, we could just say else if nums square bracket 0, sorry, that should be nums square bracket 0 equals nums square bracket 1, or nums square bracket 1 equals nums square bracket 2, then we can open up the brackets and we can say return, open up the quotation marks for the string isosceles. Boom, right? So a triangle is an isosceles if it has two sides of equal length. So if these sides equal each other or these sides equal each other, we know it's isosceles. We don't have to do num 0 equal 2 because we already handled that. And if that's the case, we have an equilateral because you have to remember the nums are sorted, right? So since we already handled this case, if this is true, then we know it's equilateral. If either one of these are true, then we know we have an isosceles. Now we have to handle the case for a scalene. A triangle is called a scalene if all of its sides are of different lengths. So for that, we could just say, come right here and say else, open up the bracket, we could just say return scalene. Sorry, y'all, open up the quotation marks, scalene. Boom, just like that. Now, if we go through all this and say something like this doesn't check out or something, or we go through all this and nothing checks out, then that means the triangle is not valid. So we could just come right here and we could say return, open up the quotation marks and a string that says none. So that should be all she wrote, y'all. It's that simple, it's that easy. I hope that makes sense to y'all. Let's go ahead and give it a run before we submit it, y'all. But that should be it. Make sure there's no typos or anything. Ooh, we got the wrong answer. So what that means, probably means there's something wrong with the math somewhere. The math is not mathing. So let's see if we can figure that out. So we have nums 0 equals nums 1. And nums 0 is equal to nums 2. 0 plus nums 1 greater than nums 2. Give me a second, y'all. Sorry about this. It should not be that difficult, but the thing about the wrong answer, oh, see, that's why you gotta check. Spelled it wrong, because I'm like, ain't no way. So in this case, we had some a spelling error. So now let's go ahead and give it a run and see if it works this time. And it's accepted, y'all. So let's go ahead and submit it. See what happens after we submit it. Let's see. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift. That's what I'm talking about. That's what I like to see, y'all. So with that being said, get one more look at the code, read it, learn it, love it, go over it, internalize it. And yeah, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.